We are now, thank you, Trevor. Your game class might rely on a turn. What are some other things that game class relies on? It relies on, how does War and Peace work again? It relies on a card class, right? Card. So it makes the game class particularly hard to test. It has dependencies, right? We used this term dependency before when we're talking about gems. But dependency, we'll add this to our vocab as well. Is any code that your class or application relies on, right? Relies on. Spelled dependency wrong. Classic. Dependency, any code that your class or application relies on, right? So the dependencies for the game class are turn and card. Some other ones as well, but these are a few of the dependencies that the game class needs to function the way it's supposed to, right? And that makes testing the game class extremely difficult. Extremely difficult. Any comments on dependencies and what makes the game class hard to test so far? Or questions? And coupled with this idea of what makes a class hard to test, these scenarios would make a test hard to class, right? Or a class hard to test. Random computer chip placements, testing for user input, extremely difficult, especially like with Ruby, right? It's like we're testing things through Ruby's input stream on the command line. What does that mean? You don't need to know too much, but it's like when you just enter something in the command line, basically. Shuffling the card deck, right? That is going to be a different outcome every single time. So how do we test something like that? The runner file. Some other things. Whenever you have an AI-like thing, right? You have a computer player that makes random moves or makes his best move as possible. That sort of thing is really hard to test. Now, the type of testing you've done up to this point is called a unit test. Does anyone have a good definition for what a unit test is if we think back to our test-driven development lesson? Any volunteers? What is a unit test? No problem. I'll provide that answer for us. A unit test is testing one class that has no dependencies, right? And so when we think about unit testing, we're testing very small pieces of functionality. We have a class, we're testing that you can create an instance of that class. We're testing a single method on that class, right? Unit testing is testing one class only and testing really small portions of that thing. It's called a unit test because you can think of multiple units of something, like make up a whole, right? And then so unit test is like the smallest piece of testing we can do. So knowing what a unit test is, which is the only type of testing we've done up to this point, right? We've tested things like the turn class, and tests that you're very familiar with, where it's like we're just testing one class and a small piece of functionality. Knowing what a unit test is, an integration test is something. It tests more than one, like object interaction, I guess is the best way to describe it. Interactions or class interactions. We won't tell you how to write integration tests in Mod 1, I'm pretty sure, but it's a concept you'll get familiar with. What's the purpose of integration tests? We would use an integration test for something like the game class, right? Somehow we want to test like the inputs, the outputs, and test and make sure like everything as an application works together, right? Integration test because it integrates multiple parts of your application, right? We won't go over how to write integration tests in Mod 1. In Mod 2, I think you get a lot of integration tests, but no, it's a concept, right? You need to write some integration tests to make sure your application works the way it's supposed to. So how have we sort of like been doing our integration test up to this point? How have you tested, it's not really an integration test because it's not automated, but how have you been testing that your components or dependencies work together in the chat? How about that? In the chat, how have we been testing things are working here? We just run the program, right? We just run the program and we're like, hey, does it work? Cool. Does it not work? Oh, shoot, something is wrong. The integration test is an automated way of testing our application, the whole part of it, right? Or maybe classes that have multiple dependencies, or just one dependency, but you have objects or classes that interact with each other. What's interesting is the game class both needs to be something that's unit tested and also something that needs to have an integration test as well. Because we want to test that the game works, right? Our application works the way it's supposed to with all these features together. But we also desire to unit test it, right? Maybe there's some functionality about the game itself that doesn't have anything to do with a card or a turn or any of these concepts, right? Maybe there's functionality about the game class itself that we need to test. One other thing, just sort of as an addition, unit tests should make up, let me fix that. Makes up like 85%-ish of your test suite. Integration test should make up like 15-ish% of your test suite. You won't write integration tests now, like I said, in Mod 1, but in the future, you're going to need them. And this is the breakdown of the percentage. Why do I say that? I say that because unit tests are fast, and they're easier to write. And integration tests are slow and take a long time to write. And that should be the breakdown, basically. You might get an interview question like, hey, do you know what the testing pyramid is? It's just this. 85% of the base makes up the unit tests, and 15% makes up integration tests, the top of the pyramid. I want everyone to write this definition down. Or this statement, basically. I'll write it here. This is not really a vocab word, but if you have multiple objects or class interaction, and you want to unit test, you need to have a mock and or a stub. Right? This is sort of our reasoning why we're talking about mocks and stubs today. This is the reason why we have a mock and stub. So if you think, hey, do I need a mock and stub here? Well, do you have multiple objects or class interaction that you want to unit test? Then yes, you need a mock and stub. I have more things to say, but I want to open up to questions for now. Are there any questions on what a unit test is. Obviously, we haven't jumped into mocks and stubs yet, but
So can I just hop in real quick?
yes.
On unit tests, it's saying test one class that has no dependencies. It's even like more granular than that. It just is a test that is contained within one class, but it's really testing like one piece of the class.
Yes, exactly. One piece of the class.
Yeah, it
This is
just
kind of maybe like when you use unit tests, right? It's like you only want to test one class, right? And less about like the exact definition of a unit test. Yes. One
so
singular unit test is like a test you create to test like the initialization of an object or the method, basically.
cool.
This talks maybe a little bit more about like the type of behavior you're testing against, right? If you're testing the behavior of just one class without any object interaction, you want a unit test. If you want to test the interaction of multiple objects together, you probably want an integration test.
It seems like we've already been doing some like small integration tests then, because like to test deck, you need to create something in like cards in the war project, and that's like below one class.
Mm-hmm. You
So with
probably
that,
have been, right?
yeah.
But by doing that, like we're creating integration tests. And what we want to do is when we have one class under test, we still want to be able to unit test it as well.
Okay.
And the purpose of kind of like a higher level view, it's like, why do we want a unit test? We want to test the class's behavior in isolation, right? And the reason for that is, let's say deck depended on cards, and we have an integration test for it, right? But let's say for some reason cards is broken, that also breaks our deck. And by creating mocks and stubs, what we do is isolate the behavior of the deck itself, the class under test, right? And you'll see that in a little bit. Basically, with mocks and stubs, we can give a method name and tell that method name what value it should have explicitly, right? Without having to rely on that particular thing.
Which is why in like the setup for war and the test you gave us, it was like assigning a card a specific value versus like generating cards, doing all that kind of stuff. Like in the test, you're just like, this is equal to this thing very simply.
Mm-hmm.
Yeah.
Here's another example, right? I use this example all the time, but let's say let's say we have a program that calculates all credit scores for like a certain region or something like that, right? Or like certain customers for a region. The thing we want to mock, let's say it just prints out, or let me think of an example actually. All right, here's an example since it's relatable. Remember our Blockbuster store video code example we went through? We have, the main purpose of it is to print out customer information, right? Like how much money they owe and how much rental points they have. The thing we would want to mock in the loop, like looping over our customers, is like how rental price actually gets calculated. Rental price is a method on the rental itself and not on the customer, right? So if we want to print out information, we don't want to have to rely on the rental price. If the rental price breaks for some reason, then our customer breaks as well, printing off customer information. So to isolate the behavior of the customer printing off information, we're going to want to create mocks and stubs to do that. All right. Hopefully as we jump into it, it'll be a little bit clearer, or at least you'll have more questions, which is also good as well. All right. This is what I want everyone to do. I'm gonna put you into some breakout rooms. See that? I'm going to paste this repository into your chat. Before you clone it down, just watch what I do. you're going to need to run gem install Mocha in your terminal. So everyone do that, please. Anywhere, it doesn't matter. It installs that Ruby gem globally on your computer. So gem install Mocha. Then I want you to clone this repo down. Clone it down. And then to get your Mocs to work, we're going to do a little bit more code exploration and less me explaining exactly how to do it. You're going to need to have this require Mocha mini test statement in your test. And the test we're going to do is the Bob test for Bob Ross, not for me. And I'm going to have a bunch of questions and prompts in the thread for the backend code help channel on what I want you to do, basically. And then we're going to spend the next like 15-ish minutes answering these questions and trying to implement it on your own. Right? I've told you like why we use Mocks and Stubs when we want to isolate the behavior we're trying to test for the class that is under test. I'm going to let you do a little exploration. Try to implement a mock on your own. That's a stretch goal. But at minimum, I want you to answer these questions that I'm going to post in the thread. All right. Either a thumbs up or a thumbs down. Do we know what we're doing after I post what you're supposed to be doing? All right, Olivia, what's the confusion? I can clear the clouds a little bit.
I get like I cloned it and everything, so now we're just trying to run whatever the question is that you're going to ask us.
Yeah, the questions I'm going to ask, basically. So I'll post those in the backend code help channel in the thread, basically. Cool? All right. I want one person to share their screen while they're doing this, if there's any code examples that we're talking about. All right, I'll see you all in a little bit. Let's see, breakout group 7. Let me see, who's in that breakout group? Chris and Will, help me answer a few of these questions to the best of your ability.
Yeah, it seemed like, let me pull it up. It seemed like it was delayed. Like the time, it was taking a long time because of that sleep in the initialize for.
Sure. So the first question is, why is test can have paint so slow? The reason is, in the initialization of paint, we have a sleep object that is 2 seconds long. And that's why our tests are really slow, right? That's why our tests are really slow. Great. Thank you, Chris. All right, Will, take over for your group. How are we adding paint instances to the Bob instance? How are we adding paint instances to the Bob instance?
Well, we're using a if this is your question, we're using a method inside the Bob class that takes an argument paint and it just shovels it into the instance variable array.
Exactly. So we are just simply taking these paint instances, right? We're creating here. Here's paint 1. We're creating an instance of it, paint 2. And via an add paint method, right? Through this add paint method, right here, as you can see in the Bob class on the right, we are just passing it in as an argument, and then that shovels it to this paints. Right? So this is, I said the definition earlier, Will, but to unit test the Bob class, what will we need to add? To unit test the Bob class, right? Isolate the behavior of adding paints. What is the thing we would need to add to our test?
I'm a little stuck on that one. I'm not sure what you need to add specifically.
Right. Would you say that currently the Bob class has multiple objects interacting with each other?
Yes, in the sense that the paint is coming from the paint class.
Yep. Yes, in the sense that the paint's coming from the paint class, right? Now we can no longer completely unit test the Bob class, right? Because we're not isolating behavior. All of a sudden we have a dependency of paint in the paint class and how it works, right? We're relying on paint to have a color method. We're relying on paint to have an amount method. These sort of things, right? Now we are dependent on paint, and we can no longer isolate the behavior of things like paint colors and total paint amount. So what we need to add is we need to add a mock. Of the Bob class under test, right? And then remember I said earlier, if you have multiple objects or class interaction to unit tests, you need mocks and stubs. In this case, we're going to talk about a mock. So what is a mock? What's the definition? It's basically just a dummy object. With no methods or behavior. Kind of redundant methods or behavior, but it has no methods behavior. It's a dummy object. And what we're going to do is we're going to use a mock in our test, basically. We need to use a mock in our test. So like I said, the Bob instance relies on the paint instance right now. In this case, the paint instance or class is a dependency. And then so we need to somehow mock the paint instances. So how we would do this is, going to comment these instances of paint out and create some new ones that are mocks. So you would need to require first Mocha mini test. Now, let's say paint 1 is just a mock, a new mock, I think, like that. Yeah. And then paint 2 is a new mock. And now this mock, how are you creating these mocks? Are from the Mocha mini test gem we just installed, right? There are methods that exist there, and they'll create mocks or dummy objects for assigning to variables here, right? Remember, a mock is just a dummy object with no inherent behavior or methods to it. Now, what's the reason we would want to do this? Well, we saw that the initialization of paint is really slow, right? This is a very contrived and maybe silly example, but there might be dependencies or other classes where you rely on some sort of calculation that takes a long time, right? And one thing about our unit tests is we want our tests to be fast. We want our tests to be fast. And the other thing is we don't want to have to rely on the paint initialization behavior to test our Bob class, right? The behavior of the paint class has nothing to do with the behavior of Bob class, right? They're separate classes, and therefore we need to separate out that behavior in some way. Now, if you had an integration test, we wouldn't, right? We would need to test both the behavior of paint and Bob, but since we're trying to unit test the Bob class and isolate that behavior, we need a mock of some sort. What are some other real world code examples where we would want to mock that behavior or create a dummy object where you don't want the actual thing? An API call, if you're familiar with that. What's an API call? It's just you make some sort of internet request to go get some data and for it to come back. But that takes like a decent amount of time. So API calls is something we would want to mock, right? We want to mock that behavior in some way. Doug, go ahead with your question.
Could you use like a mock if you hadn't built a class yet? Like, you know that, hey, this is going to be a dependent class, but I haven't gotten around to building it.
Yep.
Just mock in the expected response.
Absolutely you can, Doug. That's a great question. You can build mocks. Let's say up to this point, you've been building all your classes that support your game, right? You're building your unit testing, you're building the small components first, right? And then at the end, you're taking that all together to build your game, right? But what if for some reason you wanted to build the game from the top level, starting at the game, all the way down? Well, and you want to unit test that game, right? Well, then you could just create mocks for objects that don't exist, right? Mocks are just a dummy object. Mocks are a dummy object that have no behavior and no inherent behavior or methods on them. And as we'll see later in the lesson, you can make mocks return, or in this case, we'll talk about stubs in a little bit. You can make those dummy objects return the values that you want them to, right? You can make the mocks return the values you want them to using stubs. So what are the benefits of a mock? We isolate the behavior under test. We make our unit tests faster, right? And then also, if we want in some sort of top level design, we want to create the game class first. We can mock objects that don't exist yet, right? Because a mock is just a dummy object. All right, Angel, I think had a question. Go ahead.
So for example, you create a mock, and then once the other person, in this example, creates a paint class, would you then go back in your test, delete the mock, and then add the paint, test it with paint, or would you just leave the mock?
You just leave the mock, right? Unless for some reason you wanted an integration test that tests both Bob and paint together, you would just leave the mock. Right? Because the behavior we care about is, does Bob.paints, right? We're testing the Bob class. All we care about is, does Bob.paints return the paints here, right? And so we're really testing the add paint method. This could be anything. It could be any paints at all, essentially. And all we're testing is, do those things get shoveled into this array? And then when we call Bob.paints, right? When we reference this instance variable or method in this case, because it's add a reader, we'll return those things that get shoveled in via add paint. Add paint is the method we care about, the behavior we care about. We don't care that a paint class actually exists yet. You don't care that a paint class actually exists yet. I know it's a weird concept to think about these things in isolation. So the answer is no, you would not then come back and change these actual paint objects. You'd leave them as mocks. This is a really hard concept, by the way. So if you're not getting it now, that is just like with everything else. It's okay, right? It's hard to think of real world applicable things. It's like, oh, this is where you create a mock. It's like, why wouldn't I just create a paint instance and test that class itself? It's because we want to test the behavior in isolation, right? We want to test the Bob class, this behavior in isolation. Okay. Jake, go ahead.
Is there some value in using like paint1 is equal to mock here versus just like changing paint1 and 2 to strings and using them as strings throughout the whole time and seeing if the string gets shoveled in?
Yes, and I'll show you why that would be important later.
Okay.
That's a great point though. Here it's like, it could literally just be like any strings and we don't care. But I'll show you like why there's added value later. Okay. I think if we ran our test, it should work. Did I save it? Oh, there must be another test where it's running slowly, but yes. Cool, it still works with the mocks, right? Because all we're doing is testing, does add paint, add these dummy objects, these mocks, paint1 and paint2. And then we're asserting that when we call our instance variable, where this is a method, but it references the instance variable, does it return a collection of these mocks that we passed in, right? And it certainly does. It certainly does. Some other things I wanted to note. We're using add paint, right, to add the paint instances to the Bob class using the add paint method. What we're doing here, right, adding the paints via method, is what's known as dependency injection. Wow. What a $5 programming word, right? But if you break it down, paint is a dependency, right? Bob relies on the paint class as a dependency. And so we're just injecting that dependency via the add paint method, right? Via the add paint method. Why is this important? Well, we cannot use mocks if you're not using dependency injection in some way, whether that's via the initialization method or any method, right? In this case, it's add paint. We need to inject this dependency into this class. Just a brief example, but to have a mock, you need to inject the dependency somehow via dependency injection. We're doing it with the add paint method. All right, let's move on to some more value of, let's see, a mock is a dummy object, okay? And our next definition is a stub. What is a stub? It is a fake method we add to our mock where we can specify the return value of that method. Okay. What does that mean? And why is it important? Here's an example. Tests, it can return colors. We have some paint instances we're creating, we're adding the paints, but as before, what we're gonna do is actually create mocks, right? Because we want to isolate the behavior under test. So let's create these mocks here. Paint1, paint2. We'll add them and we'll assert equal that these paint colors equal the paint colors on the Bob instance. All right, let's run that and see what happens. Unexpected invocation mock.color. What this is saying, if we reference back to what a mock is a dummy object with no inherent behavior or methods, right? And we can see here, it's like, hey, I don't have a color method on this mock. So what we need to do is create a fake method on our mock object, basically. So we'll do that. Oh, I need to look up the syntax real quick. It is, you use the stubs method on the mock. The method you want to stub, right? The fake method, what is the fake method called? And you can add this returns, which is optional, but this is the value it returns when the color method is called, right? So we do paint1 stubs. In this case, a color method, right? That's the method we care about. And what we want the return value to be. It returns, yeah. In this case, alizarin crimson. And we'll do the same thing, let's see, for paint 2 as well, our second mock. The color we want to return is Van Dyke bread. Save it. Run our tests. Our test now pass. Now let me go over the syntax really quickly. Paint1 is a mock. And then so what we do is we're creating a fake method on it by using the stubs syntax here. What do we call that fake method? Whatever's here as we pass in an argument. In this case, it's color. And then we're saying, make your return value this string, right? Or whatever's in this parentheses. In this case, it's specific color. You can see we can return anything here. If we did this and we ran our tests, it would fail, right? Our expectation was this array of paint colors, but we specified the return value anything here as a string, and therefore our test is failing. Right? Therefore our test is failing. So you want this to actually get returned. Again, the reason we have mocks and stubs and why we want to do it is we are testing that paint colors method works the way we expect it to, right? Which is the Bob class, right? We're isolating the behavior of the Bob class by having these mocks. So you look at paint colors, it's supposed to map over every paint. It calls the color method, right? Which we are stubbing out via these lines, 37 and 38, and explicitly saying the return value. And then paints.map returns the new array, right, of paint colors, as you learned from your enumerable lesson. So we want to stub methods and explicitly return values to isolate the behavior, right? That's what we're doing here. And the stub has to happen on the mock. As we see here, paint1, we're going stubs. All right, Jesus, what's up?
So the reason why we are putting the color as a symbol, is that just that's the way the stubs work, or is that specifically the way the color or paint class is setting up the color? So like if you were to call the another method that is not a color in there, for example, add paint, would you still use a symbol, or is it just that's because of that?
Yeah, you would still use a symbol. Let me show you an example already. Remember, a stub is a fake method that we're adding to a mock object, right? We're adding some fake method and a return value. So this method doesn't, it should be, but doesn't have to be a method that actually exists on the paint class, right? It should be, but doesn't have to be. We could say fake method here. And then if we change paint colors to all our fake method, which we're adding as a via stub here, right? Our test would still pass. Right? Our test would still pass.
Okay, so yeah, so every time you call the method, it's got to be a symbol and then the method name.
Exactly.
Awesome. Okay, cool. Thank you. Appreciate that.
Sure. Good question. Looks like Karen had a question. Go ahead.
Yeah, mine was, it's similar to Jesus's. Okay, so whatever the argument is that we give stubs, that symbol of the name, it has to reflect the exact name of the method that we are faking out, basically, right?
Yes, it absolutely should. That's correct.
Okay. Why is it a symbol?
A symbol is just the argument that you have to pass into the stubs method, which exists on the Mocha mini test, right? Here's a stubs method. It just happens you have to pass in a symbol as a method name.
It's just something that Mocha requires.
Yeah, I think it's something Mocha requires, but if any, let's test it out. Let's see what happens when I pass in a string.
Okay, I have another question too.
Oh, look, it can be a string.
It worked.
Neat. Look at that. But by convention, please use color. Cool?
Yeah, can I ask another question?
Yes, absolutely.
Like, are we going over real world reasons to use Mocs?
Yes. Let me go over.
Sorry, not Mocs, stubs. Sorry.
Yes, let me go over some real world reasons. Ready? Let's go back to our Blockbuster video, right? We have some customers that we're like looping over, and we're trying to find like their total rental price or something, right? The value, the method we might want to return for the rental is like rental cost or like cost or something like that. And we want to return a specific value from that. That way, we don't actually have to rely on how the rental cost method actually works, right? We just care that it takes the sum of the thing, essentially. And then, so that would be a real world example. Does that make sense, or should I try to give you something more concrete in regards to code or words?
I think of like time. Is time a good example?
Time.
Like if we need an exact minute.
Here's a good example. I mean, here's a vague example, and then maybe I can give you another like specific example. Anytime we have some sort of calculation or method that exists in another class, right? We want to stub that method and return a specific value. Because if that dependency, the class we rely on, breaks for some reason, then the tests in this class break, right? And that's why we're creating mocks and stubs. We have dependencies. When you think about like, that's why you would want to do it. But often we do it for methods that we rely on that are time intensive in some way, right? Making an API call. You have to make a request on the internet. That takes time and something gets returned, right? What if the API is broken or something like that? Now all our tests break all of a sudden. Or there's some sort of complicated calculation we rely on as a dependency. What if for some reason that method's broken all of a sudden? Then the thing, the class that that method relies on, that object, is also broken. Is also broken. That's the best way I can explain it. In regards to real world examples or like why we want to do it. I'll try to think of more examples though as we move on. Okay, I think Doug had his hand raised. Go ahead, Doug.
If I had more than one thing for the paint class that I needed to call in a test, would I need to make an individual stub for each thing, like paint color and amount, or can I just string them onto that one stub? What's the proper way to do that?
Sorry, what's your question? If you had multiple methods you wanted to create stubs for?
Well, yeah, basically for paint one, I need to know the color I'm painting and how much for this given test. Would that be paint one stub for color and paint one stub for method? or for amount, or would that all be one stub?
I think you would need to do it individually like it's done before. I imagine there might be a way to pass in multiple stubs, but I haven't seen that sort of syntax before. But Doug, one way to like improve the test is take these paints, create instance variables out of them in your setup method, right? That way we don't have to, just like with any object that we're creating, we don't have to continually create these objects, right? We can just say, these are mocks. There you go. Use them over and over again. If you're looking for some sort of like improvement in lines of code. Great question though. All right, Chris, go ahead.
Yeah, I was just curious if stubs are dependent on mocks, or can you put do a stub on a object that you want to particularly test an attribute for?
I am 99% sure you need the stub on a mock, but we can test it, right? Let's see. Okay. Let's see if the stub works. It'll probably say, right? Well, it definitely won't work because it's going to look for a stubs method on the actual instance of the paint class, right? And then tell us there's no method called stubs there. What?
Yeah.
It looks like it works. Not what I expected. But there you go.
Thank you.
You can do that, it looks like. You can do that. You can add any fake method to any object in Ruby, apparently. There you go. Today I learned.
To
Now what I
piggyback on that, could you use that to test random attributes within your specific class? So say you had some sort of random attribute in Bob, could you stub the answer that you want instead of calling on a shuffled deck or something?
You don't want to create stubs for methods within the same class, if that makes any sense. Like if we're testing the Bob class, we don't want to stub out methods in that Bob class, right? Because we've already isolated the class behavior. So we want to actually rely on the actual methods on the Bob class, not stub those out. Because this is the Bob test, right? And we're testing the Bob class. So we absolutely do not want to create stubs for that Bob class.
Would there be a way to, and maybe you're going to get into this later, dealing with random aspects within a given class?
Yes, there is a way, and I will get into that a little bit. All right. Thanks for all your questions. There's definitely gonna be a lot of questions this lesson. It's not an easy concept to wrap your head around. All right, Alexa, go ahead.
So my question would be, say our color, like the color was actually a class. So it was like a class dependency within a class dependency. So say color had 3 attributes, RGB, like the RGB color scale.
I see what you were saying. So if this was like,
Yes, exactly.
yep.
Do you
go
create mocks for each color and then create a stub for everything? So then it would be color dot stub in parentheses R dot returns whatever hue number.
That's such a great question. And my answer is you would only need to create mocks and stubs for the paint class itself, right? Because we can define in our mock or in our stub, whatever, we can define what value like this returns, right? It doesn't need to return RGB.new or something. You could have a stub for methods within this RGB.new if for some reason you needed them, right? So you only need to create the mock at the immediate level of interaction. So this paint class, right? We would need to also create a mock for RGB. So
But what if, oh, sorry.
no. I was just show you really quick. What's this thing called? Sketchpad. So you only need to mock the thing that's one level of abstraction away, right? So for some reason, so game, you should mock the turn, you should mock the card. But for some reason, turn relied on something else here. Let's call it player, I don't know. Sorry for player, right? Well, you wouldn't need to also mock the player class. You just need to mock the thing that's one level of abstraction away, basically.
Okay, thank you.
Mm-hmm. All right. Now that your brains have thoroughly been blended, let's take a 5-minute break till 25 after. Welcome back. I will still pause for any more questions. Okay. So I think Chris was asking, how would we just check if a method was called on, right? We just want to check like it was called on at some point, which is an important thing to test. So we can also have mocks for expectations, basically. And so the syntax we would use is expects. And so what we're saying here is the paint1 mock object. We expect that the color method was called on it, and we will return this value from it, right? We expect the color method to be called on it, and we will return this value.
Can you share your screen?
Yes, I do need to do that. Thank you. So as you can see, the syntax is really similar. Expects, stubs. What the difference is this will run some sort of assertion, right? Let's say we expect the thing method to be called. And if we run our tests, we'll get a assertion failure, right? What happened? Okay, that's not, oh yeah, right here. Expected exactly once, invoked never on this mock, the thing with any amount of parameters, right? So the difference between expects and stubs is expects runs some sort of assertion. If that assertion fails, it'll tell us why. So we needed to add the word color here for this to work. Expect color to be called, and if it is called, we'll return this value, and then it passes. So the only difference between stubs and expects is expects runs an assertion of some sort. Has this method been called? That's it. So Chris, that's an example of like, yeah, has a method been called as we expected it to? Then we can have specific expectations for that using mocks, using the expects syntax. Angel, go ahead.
So when would you use expects over stubs? You may have already said this, but I'm still trying to process everything.
Sure, no problem. You want to use expects over stubs when you expect a certain method to be called, basically. right? You expect a certain method to be called. You want to run some sort of assertion that that method was called on that mock, right? So let me try to modify the example slightly. I'm trying to think of an example. I had one before and it's totally lost on me now. Let's say paint colors in Bob class both mix paint colors somehow and return their like new color, the array of new colors. New mix paint colors. And that what that relies us on to do is call like a mix color method on paint. I'm just doing this on the fly, so hopefully I can do a good job. And maybe it takes an argument of the like color, the paint color we want to mix. Every single paint color will have this new color mixed into it. All right. So if we, and then this is a command query violation, but I do it anyways. We still expect like the new colors to be returned to us, right? Please don't do what I'm doing. I'm just coming with an example on the fly. So we expect each mix, like paint to have the mixed color method called. So we might do something like this. And there is no return value, right? We expect that paint mixed color is called. Expect. If we think about mixed color, it just takes the paint color that comes in and just adds those two strings together, something like that. So we expect that those methods are just called, right? We don't care how they work underneath. We just expect them to be called in this new mixed paint color method. Like so. Let's see if I did that right one time through. Wrong number, oh, okay. Oh, we need to call this with our new color. Cool. We have a failure for color because we haven't stubbed that method up. So we will need to create stubs for the color. Something like this. Okay, still failed. Unsatisfied expression, mixed color if any parameters. All right. I can't get to the past, but this is what would be like the general idea, right? We like expect a certain method to be called, and then that creates an assertion of some sort, and then so that's what we would want, right? If it's like a procedural step in our thing to get us like the new mixed paint colors, then that's how we want to do it. Does that clarify, Angel, when we might want to use expects over stubs?
I think so.
Okay, let me provide another example. Okay. In every game, you have to check like when the game will be over, right? So some sort of conditions like it's a win, it's a loss, or a tie, right? You would expect on every single loop of the game for like a game over question mark method to be called. So you probably would have like expects game over is called like when after a game started, right? And to be called every single time the loop happens or something. That's another example. It's like you have some sort of procedural step in your program where you want to make sure that that method is called because it does some sort of thing for you in it. And then so I tried to like come up with a silly example here where it's like you expect mixed color to be called, which modifies some sort of state on the paint color. And then you want to return all the paint color eventually.
I think the game everyone clicked more.
Yeah.
So,
That's
okay,
good.
cool.
You're
Thank
all
you.
the game example might click a little bit more. So, okay. Very muddy lesson, which is totally okay. All right. So that is creating an expectation for a mock, an expectation. What I'm going to have you do in breakout groups is try to create mocks and stubs for this method, this test method. It can total the paint amount together. All right. Hopefully we're all clear on what we're doing. I'm going to put you into breakout groups and then come back together for any final questions. Let me turn.
Just a second. All right.
Wow, look at this color scheme.
I got a lot of comments on it. I didn't know it was that different.
Very pleasing to my eye.
So we, Chris and I were working on this. Just replacing the paint instantiation with mock.
Mm-hmm.
And then we added stubs because we realized when this Bob total paint amount gets called, it's actually calling the amount method on paint.
Mm-hmm.
So we had to add stubs for the amount, and then we just kind of made up our numbers so that they pass the test condition.
Awesome. That looks really great. That was a great explanation. One thing I wanted to note about just testing in general is we told you to do 67, right? Not a big deal. When you're creating tests, you want to create the simplest test cases possible. So on line 44, I would change it to the value 2. And on line 45, I would change it to the value 1. And assert that 3 equals the Bob.total paint amount. Right? Pretty easy to add. You can look at it and be like, oh, the total paint amount should be 3. Not that like 67 is hard to add to, but I'm just giving you an example of, in your test, come up with the simplest case possible to start. And then that should work, basically. But this is really a great example of how they created the mocks on 41 and 42, and the necessity for them to create a stubs for the amount method. Because as you see on 21 in the Bob class, the paint on amount method is getting called. So we need to stub that method and then return a value from that. Okay. Thanks, Will, for sharing. All right. Joseph has a question. Go ahead.
Yeah, I'm definitely still fuzzy about the difference between using stubs and expects, because I noticed you could use them interchangeably and it would still pass.
Mm-hmm. The only differences, and then I'll try to come up with another example, hopefully.
Sorry.
Yeah, no. You use expects when you want an assertion of some sort, right? You're like,
Okay.
I want to make sure this method was called.
Okay.
You use stubs when you don't need that assertion. You don't need that assertion. That's the only difference. Expects underneath the hood.
Want to make sure the method was called.
I think you would want to assure the method is called if it doesn't have a return value, right? Maybe you have a method like I said, that's a procedural method. Maybe it modifies some sort of state inside of the mock object or mock class. That's
Right. Like maybe if you're getting a random outcome or something along those lines.
Yeah, a random outcome is a great example. A random
Okay.
outcome is a great example, right? It doesn't have a specific value it returns, so you're like, I just want to make sure this thing is called.
Okay, cool. Thank you.
Mm-hmm. Okay. Doug has a question. Go ahead.
Actually, we were talking in our breakout room about a reason why you may use expects versus stubs, and I just figured I'd throw it out. In Battleship, we have criteria like must be the right number of coordinates, must be in a line, must not be a diagonal, must be on the board. You could call like an expects that my it's on the board method happen, expects that my it's the right length happens, because none of those actually return a value. You could like expects that all those methods were called, and then your return value would be a stubs, some sort of answer.
Yeah, that's a good example, right? We're talking about if your method has a bunch of procedural steps to it that don't actually return values, right? You can also have expects there as well. Great example. Everyone doesn't know about the superior setup where it's just you don't write tests at all. You just have one file for your application. But you didn't think about that one. All right. Andrew J, last question, and then we'll wrap up so you have some time before PD starts.
Yeah, so like what Doug was just saying there, like when we have the random element, like, but we want to expect that method to be run, but what are we asserting equal to when it's random? That's what I don't understand about writing tests for things that are giving us random answers.
Yeah, if it's a random result, you're just asserting that the method was called, right? And you're doing that via the expects syntax. And that's it. Like, you're just expecting that method to be called, and then you can return any value that you desire from that, right? So let's say you had a random like move generator for your computer class. So like, just makes a random move. You would do computer, which represents the mock or something, right? Computer dot move, like dot expects move, which is the method name, and then returns any value that you needed to return, right? Any value that you needed to return. Maybe it's just any random open space or whatever. It just returns a random move. And then so that's why when you might want to use expects, it's like you don't know the return value, so you just make sure the method was called the way it was supposed to.
Okay, cool. Thank you.
Mm-hmm. Okay. If you have more questions, please ask them in the thread. This is a very difficult and opaque concept. Mocks and stubs. When do you use them? Why do we use them? It's hard. It took me like a year and a half to be like, oh yeah, this is why we use mocks and stubs. I get it now. Because it seems like a silly concept, right? It's like, why don't we just like integrate our tests and just like write them as one, right? It seems kind of silly at the face, but you'll understand more and more why mocks and stubs are important for your overall testing strategy. All right. Thanks, everyone. Please ask follow-up questions.
Thanks, Bob.
Have fun at PD.
Thanks, Bob.
Thanks, Bob.
Thanks, Bob.